Hello, everyone, and welcome. Today, we're going to break down a topic that sometimes looks a bit scary, differential equations. But I promise you, by the end of this session, you'll be able to look at any of these equations and figure out its basic personality in just a few seconds. Okay, let's jump right in. So imagine you're faced with this long, complicated-looking equation. It can be a little much, right? But what if I told you there's a really quick way to size it up, to understand its basic character before you even think about solving it? Well, that's exactly what we're going to learn to do today.
And the trick is to think of it like checking someone's Instagram profile. I'm serious. When you land on a profile, you can tell a lot about it in just a couple of seconds, right? We're going to use that exact same quick check logic for these equations.
Okay, first things first, what even is a differential equation? The NCERT textbook definition is actually very simple. It's just an equation that contains a derivative. You know, something like dy by dx, or y prime, or y double prime. That's it. And why are they so special? Because they're all about rates of change. Think about it. Population growth, how fast a hot cup of chai cools down, or even the path a rocket takes. All of that is handled by differential equations. All right, so you've just landed on an equations profile. The very first thing you're going to check is something called its order. So what is the order? It's simply the order of the highest derivative you can spot in the entire equation. So if you see a y double dash, which is the second derivative, but you don't see anything higher like a y triple dash, then the order is 2. It's really as simple as that. Now, let's tie this back to our Instagram idea. The order is basically the follower count. It's that first big number you notice, and it gives you a quick idea of how complex or, influential this profile is. A higher order usually means there's a bit more going on with the equation. Okay, so we've checked the follower count. Now, for our next check, we need to look a little closer. This one is called the degree. The degree is the highest power, or you can say the exponent of that highest order derivative that we just found. But, and this is super, super important, the degree is only defined if the equation is a polynomial in its derivatives. Now, don't worry about that fancy term. It just means that the derivatives, like y prime or d squared y over dx squared, aren't trapped inside some other function like a sine or a log. They're just standing on their own. So if order is the follower count, what's the degree? Well, it's like the engagement, the number of likes or comments on their most influential post. And our most influential post is just the highest order derivative. The degree tells us the power, or the hype level, of that specific term. Look at this side-by-side comparison. It makes the difference really clear. Order is about which is the highest derivative. It's the overall influence, like a follower count. Degree is about the power of that specific term, the engagement on that one top post. And here's the key takeaway. Every single differential equation will have an order. But, and this is the main point, it might not have a defined degree at all. And that brings us to the most important rule for finding the degree, the one that will help you avoid all the common mistakes. I like to call it the public profile rule. Here's the whole idea. You can only check the engagement, which is our degree, if the Instagram profile is public. If it's private, you can't see the likes, can you? It's the same thing here. A public profile means the equation is a polynomial in its derivatives. If any derivative is stuck inside another function, its profile is private, and we just cannot define its degree. So let's make this into a super simple checklist. Step 1, find the highest order derivative. That's your top post. Step 2, ask the most important question. Is the profile public? Basically, is the equation a polynomial in its derivatives? If the answer is yes, then great. You go to step 3 and find the power of that top post. That's your degree. But if the answer is no, you just stop. The degree is not defined. Easy. So how do you spot a private profile? It's actually very easy. Just look for these red flags. If you see any derivative, doesn't matter if it's y or d squared y over dx squared, trapped inside another function like sine, cosine, e to the power of, or a log, then that's it. The profile is private. The degree is immediately not defined. Okay, enough theory. Let's actually put this into practice. It's time to check some profiles and see if you can spot the order and degree like a pro. All right, first profile, d squared y over dx squared plus y equals 0. Let's just follow our steps. 1, what's the top post? The highest derivative is d squared y over dx squared, so the order is 2. Easy. 2, is the profile public? Are any derivatives trapped inside another function? Nope, it's all clean, so yes. 3, what's the engagement on our top post? Well, the power of d squared y over dx squared is 1, so the degree is 1, and we're done. Order 2, degree 1.
Let's check this next one. Y triple prime plus y squared plus e to the y prime equals 0. Step 1, top post. The highest derivative is y triple prime, so the order is 3. Got it. Now for that crucial step 2. Is the profile public? And hang on a minute, look at that e to the power of y prime. Our y prime derivative is trapped inside an exponential function. This is a classic private profile. So we stop right there. The order is 3, but the degree is not defined. See how simple that rule makes it? Okay, last one, and this is a common tricky one. D squared y dx squared cubed plus dy dx squared equals 0. Let's do our check. Top post. The highest derivative is d squared y dx squared, so the order is 2. Is the profile public? Yep, no derivatives are hiding inside other functions. Now for the degree, be careful here. We only care about the power of the highest order derivative. Our highest one is d squared y dx squared, and its power is 3. We completely ignore that power of 2 on the other term because it's not the highest order one. So the degree is 3. Final answer? Order 2, degree 3. You've totally got this. So let's just do a quick recap of our simple profile check. First, you find the order by locating the highest derivative. That's the follower count. Then, and this is the most important part, you check if the profile is public. If it is, you find the degree by looking at the power of that highest derivative. That's the engagement. And if the profile is private, you just say the degree is not defined.
And you know what? That's really all there is to it. You now have the main skill you need to look at any differential equation and instantly understand its basic structure. This is the very first and most important step to getting comfortable with this chapter, and you're doing great.
But this does lead to a bigger question. It's cool that we can classify them, but why does it even matter? What does knowing the order and degree, the follower count, and the engagement actually tell us about how we are supposed to solve these equations? Well, that is a puzzle for our next discussion. For now, you have absolutely nailed the first step. Thanks for joining me.